10.3, we started last time, and actually we're really close to finished with 10.3. I just didn't want to cram it in because I don't like the feeling that that leaves us with when I have to. So we have a little bit left to do in 10.3, and one of the things that we have left to do is something that students often make mistakes on. Like, it's more often than not there's mistakes made on this, so it's kind of a good thing that we don't have to rush through it. What we were working on last time is the scatter plot, and we had drawn this sort of line through the middle of all the dots, trying to estimate sort of the behavior that the dots were making, right? And we gave this line the name Trendline, or a best fit line. And this is a line that closely fits the data and can be used to describe it. Now, what we're wanting to do with this line, though, is to be able to use it, which means we need an equation for it, okay? So in order to have an equation for it, it has to be some context with what's going on. For instance, you'll notice that my graph on the y-axis is not at x equals 0, right? What does the x-axis represent the way that it's drawn on our screen right now? What year? I didn't mean x-axis, the y-axis is what I meant to say. No wonder you're looking at me like I'm crazy. The y-axis. What year does the y-axis represent? Yeah, the y-axis represents the year 2000. And that's because I've got mine set up, actually, are mine set up to represent the year 2000? Oh, it's actually 01, the way I've got mine set up, which means that I had a typo from last time. So sorry. It doesn't matter what it is, we just want to make sure it's consistent with our graph. It doesn't make any difference. Yeah, I've measured mine off in units of 2s, and so 2 backwards would be the year 2001. Fabulous. So what we're doing in this one is actually creating a best fit line for the data, and I'll just create it on the screen over here itself since I have some space. So we'll give it a name. You can call it y equals if you'd like. And we need, actually, let me write a general line down first. We need 2 things for a line to have its full, ability to be used, really. We need the slope, how steep it is, and we need the y-intercept. So our y-intercept on this graph, mine on the screen anyway, looks like it's crossing at 61. Does that look right? So my b value here is going to be 61. And then I need to calculate the slope. So in order to calculate the slope, I can take any 2 points on the line, not any 2 points in all the dots, but any 2 points in the line to do that. This is actually a pretty nice point already because it's crossing at sort of a corner spot. Again, the nice thing about graph paper. So if we want to use this one would be the year, or the x value of 0. No, 1. We said it was 1. We get it right? 1, right? 2001, so this is an x value 1. No, 0, it represents the year 2001. This is why I usually start at the year 2000, is because I don't have to work through all the details like that. All right, and then it's 61, right? Okay, let's find another one. This one's pretty nice. It's actually a point on our data values. This is the point at okay, I can't keep doing this. I'm going to stop right now. Let's go backwards and just adjust something real quick. Look at that. I'll make it the year 2000 yet. That's going to make things easier for us. All right, 2000 here. This one's x equals 1, the year 2000, 0, and this is the year 2000 at the x-axis. All right. And I don't have this point right now on the graph anymore. My y-intercept is not going to be 61 anymore. Okay, let's try it again. All right, so I'm crossing at about 59.5. It's not as pretty of a value, but I'm okay with that. I can write 59.5 just fine. Now, my slope value, I need 2 points that are actually on my graph. This one looks pretty good. That's the one I was trying to get earlier. It's 364. This one looks pretty good. It's 669. So if you don't like those 2 points I picked, pick 2 other points that are on your line and use them. So to find slope, do you guys remember how we calculate slope? Do you remember? Say it for me louder, AK.
Is it x minus x over y minus y, or the other way around?
You're really close. It's the other way around. Yeah. So it's the y values subtracted on top and the x values subtracted on bottom. You might also remember sort of the just visual description, rise over run. Rise is how much you go up and down, and run is how much you go left and right. So if we're looking at these values, we have, let me shift this down so I have some more space. We have y values of 69 and 64. So 69 minus 64. And then the x value that goes with 69 is 6, and the x value that goes with 64 is 3. 69 minus 64 is 5, and 6 minus 3 is 3. This doesn't simplify any, so we'll just leave it as 5 over 3. So this is the 5 over 3x. Y equals 5 over 3x, like so. Now, I'm going to copy this to the other screen because I want a little bit more space to be able to write. This is the equation of my line, but it's not usable if that's all I have. All right, this is the part where students typically forget the details enough to make an equation usable. So our equation right here needs to have some language surrounding it to make it usable. You notice the problem that I was having when I had my x-axis sitting at 2001. It felt awkward and it's strange to be able to write it down, right? So I shifted something. But that value that I'm letting the y-axis be needs to be somehow reported in my equation when I'm writing it down. So what we actually list first is we list what this equation is going to give us. In other words, what's the output? So the output is my vertical axis. So what are my output values representing? What is it? It's the height. It's their vertical jump height. In particular, it's in inches, right? So no matter what I plug in, inches comes out. All right, I put in a date, a year specifically, and the number of inches comes out. So over here, this is inches. That's the minimum you have to write down. You have to write down inches. If you want to be more specific, you can. So this would be inches of vertical jump height. Again, your choice if you want that piece right there, but the inches has to be there. Inches comes out of this thing. And then you have to describe what you're letting your input be. And that's what we were messing around with my axis. So it's where x is the number, that's a number sign, not a hashtag, number of years after, or you can use the word since, after 2000. So whatever I let my vertical height be, not vertical height, but my y-axis be, if I had left it at 2000, I would have said years after 2001, right, if I'd left it at 2001. If I actually started with the year 2002, which I could have put 2002 on my axis, this would be years after 2002. Okay? That's what I would be representing. Why does it matter? Well, it matters because otherwise I can't use the equation. Must. This must contain the proper supporting language for it to have meaning. So your question C, it's over here, but I'll flip back in a second, says, if you use your equation, what would you predict to be the jumping height this year? Well, we're in the year 2020. We're all waiting for it to end, aren't we? It's been quite a year, 2020. But I need to know what number I plug in for x. Do I plug in 2020, the whole thing? Do I plug in 20? Do I plug in 19? Do I plug in 18? What do I plug in? Well, it's based on the language that I just ascribed to my equation. It's based on the number of years that we decided to be after the year 2000. So if we want to talk about the year 2020, how many years is that after the year 2000? 20. So 20 is the number I would plug in. Okay? So over here, we would be plugging in y equals 5/3 times 20 plus the 59.5. So go ahead and grab a calculator if you'd like. Okay. And I'll just write a note to the side here. The year 2020 is 20 years after 2000. That's why we picked it. So, I don't know what this is going to be exactly, because the last time I actually changed it in my notes, it was the year 2016, because I don't usually update them every year when I reteach the class. So, if you plug in 20, what do you get? We'll go with just 1 decimal for now of accuracy. Did anybody get one? Do you have it, Maddie? Not yet? Y'all are going to make me do this, aren't you? I have 92.8. Does that look right? Okay. 92.8 inches. Now, that's actually a really big number, number one. But also you have to realize that I'm really far outside of the data set that I was given. I really am. The last year that they gave me, I think was year 2008, wasn't it? So the idea that I would still be accurate or this would still trend exactly the same way for that extensive a time frame might not be a very accurate assessment for this particular aspect. But that's how we would calculate this aspect. If we were looking at the year 2009, we should be much more confident that the year 2009 would follow this trending line, right? If you wanted to put in the year 2050, it would be insane, right? It doesn't make any sense. So for this particular graph, the closer you are, in fact, for all graphs, the closer you are to the data set that you were given, the more accurate your estimations are going to be. All right, the last thing we're going to do, so again, the reason I mentioned early on is this language here at the end is what everybody always messes up. They either just leave it off or they don't know how to write it in. That's where people mess up. There's one other thing I might mention. Actually, it didn't come into play in this particular problem, but it could have if we weren't being careful. Notice I crossed my y-axis where I still had values. You might accidentally end up crossing the y-axis like below the x-axis or something like that, and you might have to shift your graph around to make it make sense. It needs to make sense from what's going on. For example, the way that I've got mine right here, the x-axis is the number 57. Do you see that? Got those little weird squiggly marks here, but if you counted my intervals, this is 69, 60, 59, 58. This is actually 57. So if I were looking at this and trying to use something sort of down here, I need to be very careful that I'm using the value that it actually represents. So for instance, if this crossed 1 below my x-axis, it's really not -1, right? It would be 56. So be real careful as you're looking at your scale and how you've drawn things that it's accurate to what's really going on in terms of your numerical values. All right, the last thing we're going to look at is actually talking about trend lines. Oh, we talked about it here, for example, first. Let me mention it here before we go on. We talked about the association and the association being positive. And positive means it's going uphill. We can also talk about the fact that it's positive association because it's a positive slope, right? So if we're actually given trend lines, right? These are 3 trend lines, and we're asked to find the association. In particular, is it positive or is it negative? What we're really talking about is the slope. What's the slope doing? So what is the slope doing on part A? It's negative slope, so it's going downhill, right? So the negative slope means it's a negative association. How about on B? It's positive association. C's a little bit funny. What about C? Yeah, there is none. There is no association. So you can say none or no association, something like that, because the slope's actually what here? It's 0. It's horizontal. Yeah, it's a horizontal line. The slope is 0. Let me make one mention as you start your homework or your group work here in class and then into your homework. There's some places where they give you some graphs, so it will look something like, a mess of dots like this one does. I don't need you to draw the mess of dots, okay? If you'll put your just piece of paper on top of your book or just estimate what's going on visually as best you can sketch your trend line without sketching all the dots, okay? So especially if you do, does everybody in this class have a physical book or is anybody using an electronic version? No one's using electronic? That's the best. Okay, so if you lay your paper on top of your book, you can sketch the axes and you can sort of estimate where your trend line is going to be and you can actually sketch the trend line that way. Okay? All right, so we're going to start group work. You have 3 group work problems, and then after you're done with those, we'll call it a day.